Okay, let's see the sound. Yeah, we're good. We're good. Okay, dokie. Let's get it started. Right. What's happening here? Oh, I made a typo or some sort. Oh my god. Coolios. So gonna end up watching like a few videos here, but most of the other things we are just gonna get like hands-on, and I think that should put us to, make progress moving further. I'm gonna try to organize this thing into a single folder where I say Docker, but I think I'm gonna end up changing it. Let's see. So we're gonna say here Kubernetes load secrets from AWS secret manager. That would be cool if I could do that. Create an AWS, I'm policy, and I'm user to access secrets store. Let's start by defining the I'm policy needed to access the secrets. Create a JSON file with the below content and save it to Paul external secret policy. This give me a second here. Okay. Got an email of sorts. Okay, whatever. Uh-huh. Hoppata, hoppata. External secret. Okay. Okay, we're gonna get there. I think let's do Kubernetes mini. I think it's called like Minikube or something. Yeah, there you go. So we need to getting started. Production, best practices, documentation. Motherfucker, where's the installation reference? They don't have a thing where they do just like constant releases? Like what the fuck? Oh, Snap has it. Okay, fuck it. Who the fuck wants to deal with this shit? I'm pretty sure I don't have it. Oh shit, I do have it. Uh-oh. (121) Go version 116. Go 121. What the fuck? It's installed with Snap, but I think it's been a really long time. Damn. Okay, Snap, remove kubectl. Okay, we don't have it anymore, so let's do this. Thank you. Let's go. Okay, 128 from Canonical is installed. The previous one was 121, so I think we are good. If I do kubectl, okay, now we actually see like proper shit. GStreamer libraries from the bad set. What? What the fuck is this? GStreamer libraries. What the fuck is that? Is a pipeline-based multimedia framework that links together a wide variety of media processing systems to complete complex workflows. For instance, it can be used to build systems that reads files in one format, processes them, and exports them in another. I just don't want to break my stream right now if that's like the fucking case. Yeah, let's install 120 Ubuntu 1.1.1. Okay, yeah, maybe another time. Version and client. Okay. Okay. kubectl cluster info. Okay, kubectl cluster info. Couldn't get governed server API group list. Get API timeout dial TCD hibidi for to further debug and diagnose cluster problems. Use cluster info dump. Well, my cat is meowing. He wants to go out. Guys, one sec. I'm gonna let him out, and then I'm gonna get some more tea. 1 minute. Coco, you wanna go outside, big boy? Yes, my kitty. Come, come, Coco, come. Let's go, baby. Come on, come, 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 come on, Coco. Come on, baby. Yes, my boy. Okay. Okay, back. Okay, okay. So we have okay. We got the Minikube, mini. Oh fuck! Right. Minikube start for installation. What you will need. And here's local Kubernetes, focusing on making it easy to learn and develop for Kubernetes. Only this Docker or similar to compile container or virtual machine environment. It's a single command away. Minikube start. We don't have that, so let's go. Just to make sure, yeah. Oh, it's in the thingy, Linux operating system. Debian package. RPM package. God damn it, I was trying to see the versions. Can I check? Hmm. Okay. Sudo dpkg. Okay. I downloads Minikube latest. Okay. Minikube. Okay, so we got our shit running here, which is good. I like it. Downloading Kubernetes. Motherfucker, I already have it installed. Shit. No. God damn it. Using image. GCR, that's GitHub or no? That's not GitHub, right? Mm-hmm. Kubeconfig, API server, kubelet. Okay. Minikube. I think it said dashboard. Okay, so this is where it is running. Brothers. There is nothing to display here. You can deploy a containerized app, select other namespace, or take the dashboard tour. Daemon SaaS deployments, jobs, pods, replicas as replication increase. Okay. Excuse me. Okay. So, Minikube. All right. All right. Minikube start. Open the dashboard. Okay. Okay, add-on and opens the proxy in the default web browser. You can create Kubernetes resources on the dashboard, such as deployment and service. If you are running in an environment as root, see open dashboard with URL. Create a deployment. Okay. So I haven't seen any references of Kubernetes using a Docker file instead of using an image. Fucking hate these medium posts where they like, yeah, why don't you log in? Kind list. Kubernetes API concepts. Let's kind of do a little bit of reading here. Kubernetes API is a resource-based programmatic interface provided via HTTP. It supports retrieving, creating, updating, and deleting primary resources via the standard HTTP verbs post, put, patch, delete, get. For some resources, the API includes additional sub-resources that allow fine-grained authorization, such as separate views for pod details and log retrievals, and can accept and serve those resources in different representations for convenience or efficiency. Kubernetes support efficient change. Tamer. I have a client who needs to generate like unique links on a website so clients can send documents encrypted. Just sounds like a simple backend storage with HTTPS or no? If there is no requirement on the format of the unique link, you can just use like a UUID for the link and then make sure that it's HTTPS. But again, if they want the content to stay encrypted, you might need to implement additional encryption capabilities. Because when you're making a request with HTTPS, with an SSL certificate installed, your content is only encrypted during the transfer. But when it lands the server, it gets decrypted with the thing, right? So because you're able to see the content now. I think best way to do that, like in my opinion, if they are scared of sending private information, which I understand, you create a link, a unique link per, and then you also give a lifetime to that link. Because anybody who has the link will have access to the data when they follow the link, right? Presumably. And then you don't want that link to like live a really long time. Where it lives long enough, if it gets shared, the data becomes compromised. Or you can make it like, okay, you can only visit this link like twice or 3 times or once. Yeah, then that might work too. Yeah. Yeah, then it's okay. Yeah. Yeah, just expire it right away. After its purpose is served, just expire it. Yeah, I had to implement like similar things before where, we only wanted to make sure that the intended recipient was able to access it, and then they only like accessed it at a kind of, time limited and expiration and times limited. Actually coded in Next.js. It shouldn't be too difficult, man. You need some kind of storage and then association to the media with a unique ID, and then set expiration or visibility counter. How many times it has been seen if there's a limit on that. And then assign a status that says expired. And then whenever it gets done being utilized, set it to expired. Write some unit test around it. Should be like about an hour or two maximum. Be able to finish it in Next.js. Two days of research. God damn it, bro. Yeah, in my mind, it's very straightforward. It's pretty clear, like how to go, unless they have like other requirements or constraints. Shouldn't be like too hard. Yeah, fuck you and your fucking cookies, you piece of shit. Can I at least delete the fuckers? So this is using the Google to fucking... No, this... Chrome, you are bitching. You fuckhead. Or it's just like... Give me a box of... Fuck you, Medium, you fucking piece of shit. There's a GitHub Chrome extension to remove Medium blocks. You know what? Gimme. Fuck those assholes and their fucking blocks. You're gonna sign up to see our content. No. Medium on blocker. I think this is the one that you are talking about. Let's try that. I'm fucking curious. Which one was it? This one, right? Yeah. We couldn't find? What? I just fucking visited this now. It says we couldn't find it. No way. It breaks the site? This is not something I would really trust putting on. I don't know what they are doing here. Internal server error. Nice. What the fuck? Well. Well, fuck medium.com, bro. This one works, thanks. Motherfuckers, bro. Ah, this is fucking amazing. Motherfuckers. Sign up to see the full chat. Go fuck yourself. I'll never fucking sign up to read your fucking content, bro. Just like, it makes me a fucking, like, genuinely, like, I'm gonna go the extra mile to not sign up when you make me do that. I'll run 10 miles before I do that. Open in freedom. Nah, this is good. It's okay. It's okay. I'm gonna have to remove that extension to where. Yeah, this here. It broke the thing entirely. So okay. Shit. What was I supposed to see? This one uses Medium. Yeah, I know. I know. It's just not like I don't spend that much time on Medium. It's not like my daily life revolves around Medium. Yeah, it's only when I'm trying to get information about, whatever I'm trying to resolve. Other than that, I don't really fucking care. You want to know how to do this in the language? Fuck you, pay me. I don't fucking understand. Like, I'm just trying to read. Is it like objects? Is that what it means? Okay, where is the word kind? Yeah, deployment. Here's an example manifest that shows the required fields and object spec for Kubernetes deployment. Okay, okay. So I think kind is the object. What kind of object we are dealing with here. So that makes sense. MDS Ubuntu, how you doing? What are you trying to do? Sorry, I'm trying to understand. Excuse me. What are all the possible options for the key kind? And then so I can kind of differentiate what they mean, what they don't mean, so I get a clear understanding. That's kind of what I'm trying to do. I was just trying to find a list of the potential values that goes right here, if that makes sense. Because I've never done Kubernetes before, and I want to deploy my application in Kubernetes, using Kubernetes, sorry, and then I'm kind of trying to get started. And then the second thing is, for the load balancing, if I can use Nginx, or do I have to use their own service, or can I use Nginx as a service, kinda? Maybe I'm misunderstanding it, but that's kind of what I'm trying to do. If you have any insights on that, honestly, I would appreciate it, but I don't personally know much. Do you have cluster? I just installed Minikube locally. It is running locally, and then I have the. You use Q3s. I'm using Minikube right now. Where is the fucking URL? This is not it. Did I close it by mistake? I might have. Oh, this is the one right here. This is my local dashboard. So I think I don't have anything running right now. Yeah, I don't have anything running right now. Clusters. We got no cluster. Okay, so where was I reading that? Objects. Oh, there you go. Mm, Object spec and status. Almost every Kubernetes object includes two nested object fields that govern the object's configuration, the object spec and the object status. For objects that have a spec, you have to set this when you create the object, providing a description of the characteristics you want the resource to have its desired state. The status describes the current state of the object, supplied and updated by the Kubernetes system and its components in the control plane. Having a Kubernetes object. When you create an object in Kubernetes, you must provide the object spec that describes its desired state as well as some basic information about the object, such as name, and use the Kubernetes API to create the object either directly or via kubectl. The API request must include information as JSON in the request body. Most often, you provide information to kubectl in the file known as a manifest, which is this. Okay, version apps v2. There's like a lot to unpack on this thing here. Like, what are the possible versions and what do they entail? The kinds, metadata is kind of straightforward and the spec is kind of straightforward. But how do they play together with each other? Okay, let's do here. Kubernetes use Nginx as load balancer. I know the best way to deal with Kubernetes. We just don't use them. No. Oh, there's like an example here. Let's see. Nginx Plus? What the fuck is that? Like, you have to pay for this shit? Ah, yes, like the Prime, their paid version. Thank you. Gotta pay someone? Nah. I'm pretty sure I'll fucking figure it out. Setting up an Nginx load balancer. Okay, let's do this. Kubernetes. Nginx. And load balancer. HTTPS going to be $9.99 a month. SSH for 99. Fuck. And then minus the plus because I don't want to hear that shit. Vim installation fee $300. Shit, bro. Yeah, cool. Yeah, the node port service pot. Okay. Set the service specs type to node port. Then Kubernetes will allocate a specific port on each node to that service, and any request to your cluster on that port gets forwarded to the service. You can only connect to your server 15 times a month. Load balancer. Yeah, this is the one I want. So the thing is, okay. Kubernetes, Nginx, load balancer, example, YAML. Let's see. There's got to be like some kind service, Nginx ingress, external traffic policy, local type, load balancer, ports 80 to 80, protocol TCP, HTTP 443, TCP, HTTPS. Cool. That's pretty neat, honestly. Node port. It's really cold. He opened the door. Guys, one sec. I'm gonna go close the door, get some more tea, and continue. And it is snowing. Fuck! Well, it was a long time coming, so. Blah, 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 blah. I feel like I need to watch a few videos here. Kubernetes. Tutorial, fuck it, beginners. This lady says about 1 hour. Maybe, yeah, we can do it. Right. Remind me later. Okay, and then, hold on. I've got to do the sound here. Desktop audio. Okay, so if I play this, it should...
program. If you're new here, be sure to subscribe because
If you're new here, please
upload new videos. First of all, we'll second the background. You need a hands-on demo project to get your first practical experience with Kubernetes. Now, Kubernetes is a very popular but also a very complex technology. So this crash course will help you get your first experience to get started with Kubernetes. But if by the end of the video you decide to deepen your knowledge in Kubernetes and are thinking about a career as a Kubernetes administrator, my new complete Kubernetes administrator course is dedicated to help you. Let's jump right into it. So let's jump in right into the definition. What is Kubernetes? So Kubernetes is an application physical management. Does cool actually. So to go through this chronologically, the rise of microservices caused an increased usage of container technologies because the containers actually offer the perfect host for small, independent applications like microservices. So thousands of containers. Managing those loads of containers across multiple environments using scripts and self-made tools can be really complex and sometimes even impossible. So that specific scenario actually caused the need for having container orchestration to those features. Scalability means that The application has no downtime, so it's always accessible by the users. A second one is scalability, which means you can scale your applications fast when you have more load on it and more users are trying to access it. And the same way you can easily scale it down when the load goes down. So it makes your application more flexible to adjust to the increasing or decreasing load. And the third one is disaster recovery, which basically means that if an infrastructure has some problems, like data is lost, to have some kind of application, the Kubernetes with at least one actually look like. The Kubernetes cluster is made up with at least one master node, and then connected to it you have a couple of worker nodes, where each node has a kubelet process running on it. And kubelet is actually a Kubernetes process that makes it possible for the cluster to talk to each other, to communicate to each other, and actually execute some tasks on those nodes, like running application processes. Each worker node has containers of different applications deployed on it. So depending on how the workload is distributed, you would have different number of Docker containers running on worker nodes. And worker nodes are where the actual work is happening. So here is where your applications are running. So the question is, what is running on master node? Master node actually runs several Kubernetes processes that are absolutely necessary to run and manage the cluster properly. One of such processes is an API server, which also is a container. An API server is actually the entry point to the Kubernetes cluster. So this is the process which the different Kubernetes clients will talk to, like UI if you're using Kubernetes dashboard, an API if you're using some scripts and automating technologies, and a command line tool. So all of these will talk to the API server. Another process that is running on master node is a controller manager, which basically keeps an overview of what's happening in the cluster, whether something needs to be repaired, or maybe if a container died and it needs to be restarted, etc. And another one is scheduler, which is basically responsible for scheduling containers on different nodes based on the workload and the available server resources on each node. So it's an intelligent process that decides on which worker node the next container should be scheduled on based on the available resources on those worker nodes and the load that that container needs. And another very important component of the whole cluster is actually an etcd key value storage, which basically holds at any time the current state of the Kubernetes cluster. So it has all the configuration data inside and all the status data of each node and each container inside of that node. And the backup and restore that we mentioned previously is actually made from these etcd snapshots, because you can recover the whole cluster state using that etcd snapshot. And last but not least, also a very important component of Kubernetes, which enables those nodes, worker nodes, master nodes, to talk to each other, is the virtual network that spans all the nodes that are part of the cluster. And in simple words, virtual network actually turns all the nodes inside of the cluster into one powerful machine that has the sum of all the resources of individual nodes. One thing to be noted here is that worker nodes, because they actually have most load, because they are running the applications on inside of it, usually are much bigger and have more resources because they will be running hundreds of containers inside of them. Whereas master node will be running just a handful of master processes like we see in this diagram, so it doesn't need that many resources. However, as you can imagine, master node is much more important than the individual worker nodes, because if, for example, you lose a master node access, you will not be able to access the cluster anymore. And that means that you absolutely have to have a backup of your master at any time. So in production environments, usually you would have at least 2 masters inside of your Kubernetes cluster. But in more cases, of course, you're going to have multiple masters, where if one master node is down, the cluster continues to function, smoothly because you have other masters available. In this video, we're going to learn about the main Kubernetes components that we as Kubernetes administrators or users will be working with most of the time.
Hold on, my cat is going crazy. Let me check what he's up to right now. Mr. Kitty. He's such a good cat.
To make it easier to understand all these components, I'm going to build a simple use case of a web application with a simple database. And I'm going to show you step by step how each component
fucking static scared me.
helps you deploy such an application setup and
I'm gonna
what is
fry
the
my
role
computer
of
one day
each
with
of
this
these
shit.
components. So let's start with the basic setup of a worker node, or in Kubernetes terms, a node, which is a simple server, a physical or virtual machine. And the basic component or the smallest unit of Kubernetes is a pod. So what pod is basically an abstraction over a container. So if you're familiar with Docker containers or container images, so basically what pod does is it creates this running environment or a layer on top of the container. And the reason is because Kubernetes wants to abstract away the container runtime or container technologies so that you can replace them if you want to. And also because you don't have to directly work with Docker or whatever container technology you use in a Kubernetes. So you only interact with the Kubernetes layer. So we have an application, pod, which is our own application, and that will maybe use a database, pod, with its own container. And this is also an important concept here. Pod is usually meant to run one application container inside of it. You can run multiple containers inside one pod, but usually it's only the case if you have one main application container and a helper container or some side service that has to run inside of that pod. And as you see, this is nothing special. You just have one server and two containers running on it with an abstraction layer on top of it. So now let's see how they communicate with each other in Kubernetes world. So Kubernetes offers out of the box a virtual network, which means that each pod gets its own IP address. Not the container, the pod gets the IP address, and each pod can communicate with each other using that IP address, which is an internal IP address. Obviously, it's not the public one. So my application container can communicate with database using the IP address. However, pod components in Kubernetes, also an important concept, are ephemeral, which means that they can die very easily. And when that happens, for example, if I lose a database container because the container crashed, because the application crashed inside, or because the node, the server that I'm running them on, ran out of resources, the pod will die and a new one will get created in its place. And when that happens, it will get assigned a new IP address, which obviously is inconvenient if you are communicating with the database using the IP address, because now you have to adjust it every time pod restarts. And because of that, another component of Kubernetes called service is used.
Okay, that makes sense now. See,
so service is basically a static IP address or permanent IP address that can be attached, so to say, to each pod. So my app will have its own service and database pod will have its own service. And the good thing here is that the life cycles of service and the pod are not connected. So even if the pod dies, the service and its IP address will stay. So you don't have to change that
Smiley
endpoints.
face, yeah!
So now obviously you would want your application to be accessible through a browser, right? And for this you would have to create an external service. So external service is a service that opens the communication from external sources. But obviously you wouldn't want your database to be open to the public requests. And for that, you would create something called an internal service. So this is a type of a service that you specify when creating one. However, if you notice, the URL of the external service is not very practical. So basically what you have is an HTTP protocol with a node IP address, so of the node, not the service, and the port number of the service, which is good for test purposes if you want to test something very fast, but not for the end product. So usually you would want your URL to look like this if you want to talk to your application with a secure protocol and a domain name. And for that, there is another component of Kubernetes called ingress. So instead of service, the request goes first to ingress and it does the forwarding then to the service. So now we saw some of the very basic components of Kubernetes. And as you see, this is a very simple setup. We just have...
This is in my head. What the fuck ingress really means? Ingress meaning wiper. Yo, let's go. Yes, let's go. How's it going? It's going so-so. We got started with Kubernetes because I'm going to be launching the website. So I'm going to be doing the deployment setup, hence Kubernetes. And then once this is done, the website will be up, and then I'm going to be able to do like tests against it. So that's where we are at. How you do it? Ingress, the action or fact of going in or entering. The action or fact of going in or entering. It's like when you have this night goggles, you know, night vision goggles, like you put it in, like you're like we're going in, it's like going in. That's like ingressing. The capacity or right of entrance. So it's all about like incoming thing. Okay.
Have one server and a couple of containers running and some services. Nothing really special, where Kubernetes advantages or the actual cool features really come forward, but we're gonna get there step by step. So let's continue. So as we said, pods communicate with each other using a service. So my application will have a database endpoint, let's say called MongoDB service, that it uses to communicate with the database. But where do you configure usually this database URL or endpoint? Usually you would do it in application properties file or as some kind of external environmental variable, but usually it's inside of the built image of the application. So for example, if the endpoint of the service or service name in this case changed to MongoDB, you would have to adjust that URL in the application. So usually you'd have to rebuild the application with...
Hold on, I just did my own skin faded beard. Huh? I don't follow. Did my own skin faded beard. Like you trimmed your own beard and you gave yourself a fade on your beard? Is that what it is? I think my English is hitting its limits today. Shit, it is snowing. I did a skin faded on my beard. I don't know what that means. Skin faded. I don't want to Google that because I'm scared weird shit is going to come up. It's a skin fade. Like actual human skin, right? We're not talking about like skins in a game or something. Actual human skin. So you gave yourself a skin fade on your face. Human. All right. Thank you. I got lost a little bit.
With a new version, and you have to push it to the repository, and now you'll have to pull that new image in your...
What? You sent me something? Where? I'm not gonna run Discord here because it causes me issues. I gotta fix it someday. Discord. Let's check it on the phone. Oh, I see. All right, man. Looks nice. Looks neat. Cool. What did you use to do? What did you use to do it?
Or pod and restart the whole thing. So a little bit tedious for
man.
a small change like
you have like one magic
URL.
trimmer.
So for that purpose,
hold on, I'm missing
Kubernetes
something.
has a
I can't miss this info.
and restart. Build the application that your service name in this case changed to MongoDB. You would have to adjust that URL in the application. So usually you'd have to rebuild the application with a new version, and you have to push it to the repository, and now you'll have to pull that new image in your pod and restart the whole thing. So a little bit tedious for a small change like database URL. So for that purpose, Kubernetes has a component called config map. So what it does is it's basically your external configuration to your application. So config map would usually contain configuration data like URLs of a database or some other services that you use. And in Kubernetes, you just connect it to the pod so that pod actually gets the data that config map contains. And now if you change the name of the service, the endpoint of the service, you just adjust the config map, and that's it. You don't have to build a new image. You don't have to go through this whole cycle. Now, part of the external configuration can also be database username and password, right? Which may also change in the application deployment process. But putting a password or other credentials in a config map in a plain text format would be insecure, even though it's an external configuration. So for this purpose, Kubernetes has another component called secret. So secret is just like config map, but the difference is that it's used to store secret data, credentials, for example, and it's stored not in a plain text format, but
secret data. Bro, they put so much work into that shit. That's insane. Dude, this is looking sick. Nice. Put the socials there. Nice. Nice templates, man. Cool. It's on a loop. Nice. So like the waves like move around. Dude, that's sick. Hold on, let me see if which account did you do it on? The other one? Oh, there you go. Code with Viper, I think. Let's check. Let's go. If Twitch can fucking load. God damn, come on. Yeah, my ad blocker is like really... taking his sweet ass time. There you go. Videos. Shit, you don't have your past videos open? Yeah, it's not showing up. Took long for me to start the stream because of some technical issues. No, all good, all good. No, like it's good to do like a like a few test streams, kind of like make sure your setup is good and everything. Like I've done that for sure. You will change that. It's up to you. I don't mind it. I just wanted to see how it looked. That was it. All right, let's continue because I really want to finish it today.
In base 64 encoded format. But of course, base 64 encoding a secret doesn't make it automatically secure. The secret components are meant to be encrypted using third-party tools in Kubernetes because Kubernetes doesn't encrypt them out of the box. And there are tools for that from cloud providers or separate third-party tools that you can deploy on Kubernetes to encrypt your secrets. And that will make secrets secure. So secret would contain things like credentials. And of course, database user, you could also put in config map, but what's important is the passwords, certificates, things that you don't want other people to have access to would go in the secret. And just like config map, you just connect it to your pod so that pod can actually see those data and read from the secret. You can actually use the data from config map or secret inside of your application pod using, for example, environmental variables, or even as a properties file. So now let's see another very important concept generally, which is data storage and how it works in Kubernetes. So we have this database pod that our application uses, and it has some data, or it generates some data. With this setup that you see now, if the database container or the pod gets restarted, the data would be gone. And that's problematic and inconvenient, obviously, because you want your database data or log data to be persisted reliably long term. And the way you can do it in Kubernetes is using another component of Kubernetes called volumes. And how it works is that it basically attaches a physical storage on a hard drive to your pod. And that storage could be either on a local machine, meaning on the same server node where the pod is running, or it could be on a remote storage, meaning outside of the Kubernetes cluster. It could be cloud storage, or it could be your own premise storage, which is not part of the Kubernetes cluster. So you just have an external reference on it. So now when the database pod or container gets restarted, all the data will be there, persisted. It's important to understand the distinction between the Kubernetes cluster and all of its components and the storage. Regardless of whether it's a local or remote storage, think of a storage as an external hard drive plugged into the Kubernetes cluster. Because the point is, Kubernetes cluster explicitly doesn't manage any data persistence, which means that you as a Kubernetes user or an administrator are responsible for backing up the data, replicating and managing it, and making sure that it's kept on a proper hardware, etc. Because it's not taking care of Kubernetes. So now let's see everything is running perfectly and a user can access our application through a browser. Now with this setup, what happens if my application pod dies, right? Crashes, or I have to restart the pod because I built a new container image. Basically, I would have a downtime where a user can reach my application, which is obviously a very bad thing if it happens in production. And this is exactly the advantage of distributed systems and containers. So instead of relying on just one application pod and one database pod, etc., we are replicating everything on multiple servers. So we would have another node where a replica or clone of our application would run, which will also be connected to the service. So remember previously we said the service is like an persistent static IP address with a DNS name, so that you don't have to constantly adjust the endpoint when a pod dies. But service is also a load balancer, which means that the service will actually catch the request and forward it to whichever pod is least busy. So it has both of these functionalities. But in order to create this second replica of the My Application pod, you wouldn't create a second pod, but instead you would define a blueprint for a My Application pod and specify how many replicas of that pod you would like to run. And that component or that blueprint is called deployment, which is another component of Kubernetes. And in practice, you would not be working with pods, or you would not be creating pods. You would be creating deployments, because there you can specify how many replicas, and you can also scale up or scale down the number of replicas of pods that you need. So with pod, we said that pod is a layer of abstraction on top of containers, and deployment is another abstraction on top of pods, which makes it more convenient to interact with the pods, replicate them, and do some other configuration. So in practice, you would mostly work with deployments and not with pods. So now if one of the replicas of your application pod would die, the service will forward the requests to another one. So your application would still be accessible for the user. So now you're probably wondering, what about the database pod? Because if the database pod died, your application also wouldn't be accessible. So we need a database replica as well. However, we can't replicate database using a deployment. And the reason for that is because database has a state, which is its data. Meaning that if we have clones or replicas of the database, they would all need to access the same shared data storage. And there you would need some kind of mechanism that manages which pods are currently writing to that storage or which pods are reading from that storage in order to avoid data inconsistencies. And that mechanism, in addition to replicating feature, is offered by another Kubernetes component called stateful set. So this component is meant specifically for applications like databases. So MySQL, MongoDB, Elasticsearch, or any other stateful applications or databases should be created using stateful sets and not deployments. It's a very important distinction. And stateful set, just like deployment, would take care of replicating the pods and scaling them up or scaling them down, but making sure that database reads and writes are synchronized so that no database inconsistencies are offered. However, I must mention here that deploying database applications using stateful set in Kubernetes cluster can be somewhat tedious. So it's definitely more difficult than working with deployments where you don't have all these challenges. That's why it's also a common practice to host database applications outside of the Kubernetes cluster and just have the deployments or stateless applications that replicate and scale with no problem.
Yeah, that's what I'll do. I'm going to have like an RDBS.
Communicate with the external database. So now that we have two replicas of my application pod and two replicas of the database, and they're both load balanced, our setup is more robust, which means that now even if node 1, the whole node server was actually rebooted or crashed and nothing could run on it, we would still have a second node with application and database pods running on it, and the application would still be accessible by the user until these two replicas get recreated, so you can avoid downtime. So to summarize, we have looked at the most used Kubernetes components. We started with the pods and the services in order to communicate between the pods, and the ingress component, which is used to route traffic into the cluster. We've also looked at external configuration using config maps and secrets, and data persistence using volumes. And finally, we've looked at pod blueprints with replicating mechanisms like deployments and stateful sets, where stateful set is used specifically for stateful applications like databases. Just using these core components, you can actually build pretty powerful Kubernetes clusters. Before moving on, I want to give a shout out to Keston, who made this video possible. K10 basically takes from the class I work with my link, you can your Kubernetes container. We actually create those components like pods and services to configure the Kubernetes cluster. All the configuration in Kubernetes cluster actually goes through a master node with the process called API server, which we mentioned briefly earlier. So Kubernetes clients, which could be a UI, a Kubernetes dashboard, for example, or an API, which could be a script or a curl command, or a command line tool like kubectl. They all talk to the API server and they send their configuration requests to the API server, which is the main entry point or the only entry point into the cluster. And these requests have to be either in YAML format or JSON format. And this is how an example configuration in YAML format actually looks like. So with this, we are sending a request to Kubernetes to configure a component called deployment, which is basically a template or a blueprint for creating pods. And in this specific configuration example, we tell Kubernetes to create 2 replica pods for us called my app, with each pod replica having a container based on my image running inside. In addition to that, we configure what the environment variables and the port configuration of this container inside of the pod should be. And as you see, the configuration requests in Kubernetes are declarative form. So we declare what is our desired outcome from Kubernetes, and Kubernetes tries to meet those requirements. Meaning, for example, since we declare we want 2 replica pods of my app deployment to be running in the cluster, and one of those pods dies, the controller manager will see that the is and should states now are different. The actual state is 1 pod, our desired state is 2. So it goes to work to make sure that this desired state is recovered, automatically restarting the second replica of that pod. So here I have examples of a deployment and service configuration files side by side. So the first thing is that every configuration file in Kubernetes has 3 parts. The first part is where the metadata of that component that you're creating resides. And one of the metadata is obviously name of the component itself. The second part in the configuration file is specification. So each component's configuration file will have a specification where you basically put every kind of configuration that you want to apply for that component. The first 2 lines here, as you see, is just declaring what you want to create. Here we are creating deployment, and here we're creating a service. And this is basically that you have to look up for each component. There's a different API version. So now inside of the specification part, obviously the attributes will be specific to the kind of a component that you're creating. So deployment will have its own attributes that only apply for deployment, and the service will have its own stuff. But I said there are 3 parts of a configuration file, and we just see metadata and the specification. So where's the third part? So the third part will be a status, but it's going to be automatically generated and added by Kubernetes. So the way it works is that Kubernetes will always compare what is the desired state and what is the actual state or the status of that component. And if the status and desired state do not match, then Kubernetes knows there's something to be fixed there, so it's going to try to fix it. And this is the basis of the self-healing feature that Kubernetes provides. For example, here you specify you want 2 replicas of Nginx deployment. So when you apply this, when you actually create the deployment using this configuration file, that's what apply means, Kubernetes will add here the status of your deployment, and it will update that state continuously. So for example, if the status at some point will say just 1 replica is running, then Kubernetes will compare that status with the specification, and we'll know there is a problem there. Another replicant needs to be created ASAP. Now, another interesting question here is, where does Kubernetes actually get the status data to automatically adhere or update continuously? That information comes from the etcd. Remember the cluster brain, one of the master processes that actually stores the cluster data. So etcd holds at any time the current status of any Kubernetes component, and that's where the status information comes from. So as you see, the format of the configuration files is YAML.
Okay, let's see. Apps v1 versus v1. Yeah, what the fuck is that? What is the difference between apps and extensions? Oh, damn. The apps API group will be where the v1 deployment type lives. The apps v1 the version was added in 1.6, so if you have 1.5 client or server, you should still use the extension. Apps are identical, but when creating via the apps API, some improved defaults are used. Motherfucker, that's not really... Breadcrumb! Justin saved me from the bad code. What's going on, my dude? Okay, there you go. What does each API version mean? All right, there you go. API versions with alpha in their name are early candidates for, beta in the version means that testing has progressed past alpha level and okay, stable, they are safe to use. V1 version was the first stable version release of the Kubernetes API. It contains many core objects in Kubernetes. Apps v1. Apps is the most common API group in Kubernetes with many core objects. It includes various functions like running applications on Kubernetes, like deployments, rolling updates, and replica sets. Auto-scaling versions supposed to be auto-scale based on the different resources and cause scaling a cluster up and down is totally dependent on demand. Includes support for only CPU scaling, but feature alpha and beta versions allow you to scale based on memory used in custom metrics. Dealing with some really edge case weird C# shit, and it's exhausted me. 2 work days on this stupid shit down the drain. My coding life as of late has been just awful. It's been awful. Oh man, I'm sorry to hear that. Shit, if I knew C#, I would be, like, let's check it out, but I don't know. Are you streaming this? I didn't see you on last night, and I don't see you on right now either. So, yeah, what's happening? No one knows. Gotcha. What is this code about? It's work stuff. Gotcha. Yeah, wish I knew some C# so I could, like, help you out, man. Basically trying to enable a project to be unit testable. Oh, okay. Again, not experienced. Fuck. Is it like, what is your struggle? Is it like the design is getting in the way, or is it like your entry point is not really like doing its shit? It's nothing you'd be able to help with, just came into bitch. Gotcha. You are here to vent. All right. Yes, sir. And pump. Bro. Hell yeah, baby. Yeah, I'm going through this tutorial with this lady called Nena. I'm not sure how she pronounces her name, but we are making progress. So I'm hoping to get it up and running locally today, and then tomorrow I'll push it up to the actual website, so it will be available on the domain name. But mostly, like, I'm learning as I go here. Because yesterday I finished unit tests, everything is good, and then it's time for the deployment. So I can get maybe like I'm gonna try to find some people to test it. Get here, and then address any like immediate bugs, and then get it ready for actual release. DevExpress basically said if you put our library in your code, you can't unit test anymore. So I'm trying to figure out how to get around their idiocy. Oh boy. What is DevExpress, by the way? Is there something I can Google? DevExpress. So UI library, this is the one. They make controls for everything. Okay, hold on. DevExpress C#. Okay, .NET. There we go. Let's go over here. Support docs. Documentation. Anything about tests? Motherfuckers, there's no. They released their Maui library for free. Maui library? Maui C#. Is that the one? Cross-platform maps in C# from a single shared code base in Visual Studio, share UI layout and design across platforms, share code tests, and business logic across platforms. How does it work? Hot reload, cool. Okay. Maui C# unit test. So there is apparently a thing for that. It's just that how to do unit testing in C#. I'm saying Maui in like fucking quotes, but it still doesn't net my forget me not unit 7 unit testing. I would look at like some example codes that others have created and then see if you can utilize that in yours. Fact, populate bodies, sort true body list and the count 0. What's going on? I'm going to empty list of body objects not created into the body which I add to the list. And I did a cool part. I created a mock for my service with that one line. Did the body service. The subject wants interfaces. So earlier I went to each class in my services, put the cursor on the class name and use wrapping up. Interesting. Broke down and wrote a question. Oh boy. This is like just today. Yeah, you might end up having to wait a little bit and then see like what people come up with. Keep an eye on your post. People might ask like follow-up questions. Wrote it and then decided to come dump on you more. Yeah, I mean, hopefully it will, someone can like point you in the right direction or give you like some kind of insight there. None of the things there is actually like something I know, so. But you never know. Talking to me might trigger something in your head. Oh shit. Hold on. It's snowing. Oh. Snow is like slowly holding. It's so cold, it's not melting at all. Jesus. Need to get you a rubber duck mask. I've been wanting to buy a really big rubber duck, but man. Like the big one. Giant duck toy. Look at this big boy. Didn't know that was a thing forever, rubber duck programming. It is. I want this like giant motherfucker here. Holy shit. Hold on. This is $217 and it's smaller than a fucking towel? What the fuck? What's the dimensions on this bitch? $30 centimeters and you want $218? Get the fuck out of here. Is it much better at listening to your code concerns? I just want a really big, all right, I'm gonna say here, rubber duck giant, let's say like giant. This is not giant, motherfucker. Okay, this is maybe, what the fuck it is? What? Bro, what am I looking at here, bro? Imagine how quickly you'd fix your code if you had a dock that big. Yeah, he can slap you into solution. 9 inches tall pull toy. 9 inches. That's what she said. What the fuck is wrong with me? Oh, damn. Look. This is what I want. I mean, this doesn't really look like this, but I want this to be like looking like this big. What the hell is this? I want this. Imagine like you have this in your background just sitting there. We'd be fucking at me. Bro, what the fuck are these pictures sometimes? They're just like cracking me up. What? This could work. I kind of like this here. But I don't understand the prices here, bro. $240? Jesus. For a fucking plastic piece of shit. Let's continue. Okay.
That's why the extension here. And generally, it's pretty straightforward to understand. It's a very simple format, but YAML is very strict about the indentations. So, for example, if you have something wrongly indented here, your file will be invalid. But other than that, it's pretty simple. Another thing is, where do you actually store those configuration files? A usual practice is to store them with your code, because since the deployment and service is going to be applied to your application, it's a good practice to store these configuration files in your application code. So usually it will be part of the whole infrastructure as a code concept. or you can also have its own Git repository just for the configuration files. So in this video, I'm going to show you what Minikube and kubectl are.
That's what I have.
How to set them up.
I installed both of them.
First of all, let's see what is Minikube. Usually in Kubernetes world, when you're setting up a production cluster, it will look something like this. So you would have multiple masters, at least 2 in a production setting, and you would have multiple worker nodes. And master nodes and the worker nodes have their own separate responsibility. So as you see on the diagram, you would have actual separate virtual or physical machines that each represent a node. Now, if you want to test something on your local environment, or if you want to try something out very quickly, for example, deploying new application or new components, and you want to test it on your local machine, obviously setting up a cluster like this will be pretty difficult, or maybe even impossible if you don't have enough resources,
emoji,
like
I'm liking
memory
it, bro.
and CPU, etc. And exactly for the use case, there's this open source tool that is called a Minikube. So what a Minikube is basically one node cluster where the master processes and the worker processes both run on one node. And this node will have a Docker container runtime pre-installed. So you will be able to run the containers or the pods with containers on this node. So now that you have this virtual node on your local machine that represents Minikube, you need some way to interact with that cluster. So you need a way to create pods and other Kubernetes components on that node. And the way to do it is using kubectl, which is a command line tool for Kubernetes cluster. So let's see how it actually works. Remember we said that Minikube runs both master and worker processes. So one of the master processes called API server is actually the main entry point into the Kubernetes cluster. So if you want to do anything in the Kubernetes, if you want to configure anything, create any component, you first have to talk to the API server. And the way to talk to the API server is through different clients. So you can have a UI like a dashboard. You can talk to it using Kubernetes API or a command line tool, which is kubectl. And kubectl is actually the most powerful of all the 3 clients, because with kubectl you can basically do anything in the Kubernetes that you want. And throughout this video tutorials, we're going to be using kubectl mostly. So once the kubectl submits commands to the API server to create components, delete components, etc., the worker processes on Minikube nodes
Finish the meeting. Welcome back.
Make it happen. So they will be actually.
We're gonna start running the code here pretty soon, most likely.
To destroy the pods, to create services, etc. So this is the Minikube setup, and this is how kubectl is used to interact with the cluster.
Yeah.
An important thing to note here is that kubectl isn't just for Minikube cluster. If you have a cloud cluster or a hybrid cluster, whatever, kubectl is the tool to use to interact with any type of Kubernetes cluster setup. So that's important to note here. So now that we know what Minikube and kubectl are, let's actually install them to see them in practice. Now let's see how to install and run Minikube. There are many different ways depending on your operating system and its architecture. So the best way is to reference the official documentation. And here, as you see, Minikube can run either as a container or a virtual machine. And these are the resource requirements to run Minikube on your machine.
We already installed this, so I'm just gonna
And as you see, the latest Minikube version has been installed. Once Minikube is installed, we want to actually start or create a Minikube cluster, which is also super easy, as you see. We simply execute a Minikube start command. However, as I mentioned, Minikube must start either as a container or a virtual machine. So we need either a container or a virtual machine tool installed on our laptop to run Minikube. And this is going to be the driver for Minikube. And opening the drivers page, you see the list of supported drivers.
Yeah, we have Docker, so Linux, we don't have to worry about it. And Windows, this one I want to use anyway.
And you see that all operating systems. Now this cluster, we run Docker containers. And it's important to note here that Minikube installation actually comes with Docker already installed to run those containers. But Docker as a driver from Minikube means that we are hosting Minikube on our local machine as a Docker container itself.
Gas tank
so we
for
have
oxygen.
two
Holy
layers
shit! What?
of Docker.
I hope he's
Minikube
okay, man.
running as a Docker container,
Damn.
and inside Minikube we have Docker packaged in Minikube to run our application containers. And for hosting Minikube on our machine, we can use Docker. So if you have Docker already installed on your machine, you're all set up to start a Minikube cluster. If not, also not a problem. You can easily install it from here. So clicking on install Docker link, this will take me to Docker Hub,
hopefully, yeah.
where I have Docker desktop installation for Windows, Docker desktop for the applications. So the link, installation may take some time, but once Docker is installed and running, we can switch back to the terminal and start the Minikube cluster using Minikube start command, passing Docker as a driver option using the driver flag with Docker value. And let's execute.
I think I didn't do it, but like it for me, Minikube status, we are running Minikube. Can I do like stop? All right. Ew. They are using emotes in the thing. Cool. We're gonna say start driver Docker. I think that's like what it was doing anyways. So restarting existing Docker container for Minikube. Oh my goodness. Is Minikube the one that Ubuntu developed, or is that K3's? Honestly not sure. I think Minikube is what Ubuntu developed. Minikube versus K3S. K3's Minikube and MacroK are different ways to spin up Kubernetes clusters. Each of these solutions achieve their intended purposes with different goals. Minikube you can run on Windows and macOS because it relies on virtualization to deploy a Kubernetes cluster in a Linux VM. You can also run Minikube directly on Linux with or without virtualization. It also has some developer-friendly features like add-ons. Currently limited to a single node Kubernetes cluster. For them to see this issue, although it's on their roadmap. MacroK is kind of the of all the Kubernetes offerings, I know the least about this one. Similar to Minikube is that it spins up a single node Kubernetes cluster with its own set of add-ons. Like Minikube is limited to the single node Kubernetes cluster with the added limitation of only running on Linux and only on Linux where Snap is installed. Oh dang. K3 is run on any Linux distribution without any additional external dependencies or tools. It is marketed by Rancher as a lightweight Kubernetes offering suitable for edge environments, IoT devices, CI pipelines, and even ARM devices like Raspberry Pis. K3 achieves its lightweight goal by stripping a bunch of features out of the Kubernetes binaries, legacy alpha, and cloud processor features, replacing Docker with container D, and using SQLite 3 as a default DB instead of etc. As a result, the lightweight Kubernetes only concerns with RAM and terminal with disk space has some nice features like Helm chart support out of the box. Unlike the previous two offerings can do multiple node Kubernetes cluster, however, due to technical limitations of SQLite 3 only does not support high availability, as in running multiple master nodes. The K3's team plans to address this in the future. Honorary mentions. Kubernetes in Docker, as the name implies, runs Kubernetes clusters and Docker containers. This is the official tool used by Kubernetes maintainers for Kubernetes conformance testing. It supports multi-node clusters as well as HA clusters because it runs KS in Docker. Client can run on Windows, Mac, and Linux. Is optimized first and foremost for a CI pipeline, so it may not have some of the developer-friendly features or other offerings. Desktop Docker ships with bundled Kubernetes offering. Oh, I did not know that. K3, any project that aims to bring K's Docker similar to kind, they're still working through some issues like exposing the right Docker project. Zero, Kube ADN. Okay, so there's like, they're not the same, but they are like with the same purpose, apparently. All right, let's continue. So we did that.
And this may also
Alright,
take a
we're
while
good.
when you're running it first time, because it needs to actually create the cluster and download all the necessary images and components. So the next time you do minikube start, it should actually go faster. And as you see, this command created a local Kubernetes cluster on our machine with the latest Kubernetes version 1.22. And now we can check the status of the cluster using minikube status command. And we see that all the components inside are running and everything is configured. And now start to actually interact with our cluster using kubectl command line tool. And kubectl actually gets installed as a dependency when we install minikube.
Shit, I don't know. I installed kubectl separately.
Installing dependencies for minikube, and Kubernetes CLI is actually kubectl. And that means we already have that available. We don't have to install it. So now I can do kubectl get node. And this will display all the nodes in the cluster. In our case, we just have one node, which is control plane.
Kubectl get node. Minikube ready. Control plane. Ooh. So get node or get nodes, they're the same. Okay.
And the worker node at the same time. And we see information for each node, like the status, the Kubernetes version that it's running, as well as when it was added to the cluster. So with this, we now have an actual Kubernetes cluster running locally on our machine. And we can start deploying applications in it. So from this point on, we're going to be interacting with the minikube cluster using kubectl command line tool. So minikube is basically just for the startup and for deleting the cluster, but everything else, configuring, we're going to be doing through kubectl. Now we have enough knowledge to deploy a very simple but realistic application setup in a Kubernetes cluster. We will deploy a MongoDB database and a web application which will connect to the MongoDB database.
Yes, let's do it!
Configuration data from config map and the secret. And finally, we will make our web application accessible externally from the browser.
Yes,
so
ma'am!
Let's get right in. So I have two
Hold
resources.
On. I'm going to take out my food from the fridge so it doesn't. Okay, I'm back. Relax. I'm back. Static. Fuck.
This year, we're going to reference the Kubernetes documentation to create our components, which is a realistic way of working with Kubernetes, and also a Docker Hub where I have the web application image that I created, which is publicly accessible, so you can also pull it directly from the Docker Hub in your Kubernetes cluster. So first, let's go ahead and create all the Kubernetes configuration files that we need for deploying our application setup. And for that, I'm going to go to Visual Studio Code, where I have a Kubernetes demo folder open. And in this folder, we're going to create 4 Kubernetes configuration files that we need. We're going to create a config map with MongoDB database endpoint. Okay. We're going to create a secret with username and password for MongoDB.
Thank you very much.
Create a configuration file for deploying a MongoDB application and its service. And then we're going to create a Kubernetes configuration file for deploying our simple demo app application with its service.
Okay.
So the first file will be called mongoconfig.yaml. And creating a config map in Kubernetes is super simple. For the syntax, we can reference the Kubernetes documentation. So I'm going to copy the first part here, paste it in, And that's basically the main syntax we're starting from. Let's call our config map Mongo config. So we have the metadata, and then we have the actual contents of this config map. Within the data attribute, we have all the key value pairs that we define as external configuration within this config map. In our case, we just have one, which we're going to call Mongo URL as a key. And of course, we need a value for the MongoDB URL. And the value will be the service that we're going to create for MongoDB application. And we're going to call that service Mongo service. And in a couple of minutes, you're going to see how to create this Mongo service. And that will be basically all the configuration we need for creating config map. So that one is done. Let's now go ahead and create Mongo secret.yaml, which will hold the username and password for MongoDB application. Again, to reference documentation, I'm going to take this one and let's actually copy the whole thing.
Okay, now it's like starting to make more sense to me.
Kind instead of config map. Let's call this Mongo secret. We have type opaque, which is the generic type for defining secret data, basically. And we have the same data attribute here. And let's actually create our own values. Let's call this Mongo user and Mongo password.
Okay.
And as you already learned, the values in secret are base64 encoded. So we can't just set the values plain text. We have to encode them first. And encoding values is super easy. We're just going to do echo. And let's call it Mongo user and base64 encoded. And the same way, let's do Mongo password.
Damn! Me like it. Hold on, can you do this on Linux?
Hold
on, I'm curious. Echo and username base64. If I can type, it would be nice. I can see the suggestion already. Okay, let's go, lady.
And this will be our secret configuration. And now, when we create deployments for our applications, we can reference any of the values defined in the secret or config map. So let's see how that
That's what I'm talking about, Nana. You show us the way.
Again, let's create a new file. And let's call this mongo.yaml. This is going to be a configuration file where we're going to create deployment and service for MongoDB. You can have separate files for them, but it's a very common thing to put them together because all the deployments need services. So you have them grouped in one YAML file.
Yes.
And again, let's reference the documentation for
guys, how was the sound? I didn't check
the deployment example syntax. And
can you guys hear this okay?
Adjust the values as we need. And as you see, deployment configuration file looks a little bit more complex than config map or a secret. So let's go through the configuration and understand all these attributes. So we have the metadata section and the specification. And these are basically deployment specific configuration that we have in the specification section. And let's start with the main part of the deployment, which defines the blueprint for the pods. And that blueprint is defined as a template. So template basically is a configuration of the pod within the configuration of deployment. And you see that template section has its own metadata and own spec or specification.
So that's how it looks when you like put them in the same file
and specification, right? So this part actually configures the pod within a deployment. And in the specification of the pod, we have the definition of containers. So this is a list of containers. As you learned, you can have multiple containers in a pod, but mostly one main application per pod. And this is where we define which image will be used to create this pod. In our case, this is going to be a MongoDB image. And if we search for Mongo in Docker Hub, that's basically the image name. And you can find all the tags in the text section. And we're going to use the tag 5.0. So Mongo 5.0. That's where we define the image of the container within the pod. We can name this MongoDB. This is just the name of the container. And we also have the port where the container will listen. And let's check our image. And as you see, MongoDB starts at this port. So we can just copy it and paste it in here. So this basically just configures our deployment to create pods with a MongoDB image version 5.0. So that's the core of a deployment. Now let's see what is all this other stuff here. First of all, we have this labels attribute in the metadata section. And then we also have match labels attribute. So what is this about? In Kubernetes, you can give any component a key value pair labels. So you can label anything from pod to deployment to config map, etc. And labels basically are additional identifiers of the components in addition to the name, for example. So you can identify and address specific components using their labels. Now, why do we need them? First of all, when we have multiple replicas of the same pod, each pod will get a unique name. However, they can share the same label. So we can identify all the pod replicas of the same application using a specific label that all of them share. And that's why in the metadata of the pod, we always have this label. So for pods, labels is a required field. For other components like deployment, config map, etc., labels is optional, but it is a good practice to set them. Now, when we create pod replicas, how does deployment know which pods actually belong to it? Or how does Kubernetes know which pods belong to which deployments? And that is defined using this part right here. So selector match labels is in the specification of the deployment, as you see. And this defines that all the pods that match this label belong to this deployment. So that's why we have match labels here. So this selector will match the pods created with this configuration because they have label app nginx. Now, are these labels given or can you select any key value pairs? Well, these are totally up to you. You can call it whatever you want. You can call it my key, my value. It doesn't really matter. However, the standard and a common practice in Kubernetes is to use app key in the labels when labeling your applications. And the value will obviously be whatever application you have. So let's actually change and set the values to Mongo instead of nginx, because that's our application. And of course, we want to match label app Mongo. And let's also change this one right here to Mongo deployment. And finally, last attribute we have here is replicas, which is super simple and straightforward. This just defines how many pods you want to create using this blueprint. In our case, let's do just one replica because it's a database. And as you learned, if you want to scale databases in Kubernetes, you should use stateful set and not a deployment. To keep everything simple, we're going to stick to one replica. And that basically configures our MongoDB deployment and the pod blueprint. Now let's add a service configuration because every application needs a service in Kubernetes, and that's going to be a separate YAML unit or YAML section, and we're going to separate it using 3 dashes, which is basic YAML syntax, nothing specific to Kubernetes. And again, let's grab a service example. And adjust it as we need. Now, service configuration is much easier than the deployment, as you see. First, let's change the name. Let's call it Mongo Service. And remember, this is the endpoint which we will use to access Mongo, and that's what we defined right here. So this is the name of the service. And in the specification, we have service-specific attributes. First of all, we have the selector attribute, which you already know from here. Now, why do we need a selector in service? Because, as you know, service needs to forward the request that it gets to its endpoint pods. How does service know which pods belong to it and which ones it should forward the requests to? Well, using the same label selector as we saw on deployment. So this should match the label of the pods that will belong to the service, which is app Mongo. And that's how service and pods will find each other. And then we have the ports configuration, which is also super simple. Service is accessible within the cluster using its own IP address and the port, and we define its port right here. This should, you know, from
Sorry.
and in the specification,
Let's do it again.
We have service-specific attributes. First of all, we have the selector attribute, which you already know from here. Now, why do we need a selector in service? Because, as you know, service needs to forward the request that it gets to its endpoint pods. How does service know which pods belong to it and which ones it should forward the requests to? Well, using the same label selector as we saw on deployment. So this should match the label of the pods that will belong to the service, which is app Mongo. And that's how service and pods will find each other. And then we have the ports configuration, which is also super simple. Service is accessible within the cluster using its own IP address and the port, and we define its port right here. And this can be any port that we decide on. This could be 80, 8080, doesn't really matter. And we have the target port, which is the port of the pods that belong to the service. And logically enough, the target port should always be the same as the container port, because that's where the application in the pod is accessible. Now that's where the service should forward the request to. So again, very important, port attribute sets the port of the service, and target port tells service to which port it should forward the request to the pods. And this should be same as the container port. Port and target port values can be different, or again, it's a common standard to select the same port for the service as well, just to keep things simple. So let's save this, and that's our configuration for MongoDB deployment and service. Now I'm going to copy this whole thing and create a deployment and service for web application for our Kubernetes demo application. And let's call this web app.yaml. Paste everything in, and we can just adjust all these values. In the service and deployment, all the labels and label selectors, of course. And right here, we of course need the correct image of our web application. Going back to our Docker Hub, this is the name of my image. And again, this is publicly accessible, so you can use it as well. And the tag is v1.0. And there you go. So this is a very simple Node.js application, which starts on port 3000. So that's why we need to define container port on 3000. And container port is same as target port on the service. And we can set the service port to the same value. And this will configure deployment and service for our web application.
Cool.
So this is the basic configuration for deployment and service for any application in Kubernetes cluster. But we have one more thing to configure in our deployment components for both Mongo and web app, which is we need to pass the data defined in the config and secret components. First of all, when starting a MongoDB application, we need to set username and password. So when MongoDB application starts, it will automatically generate a username and password for MongoDB, and we can then use that to access it in our cluster. Now, how do we know how username and password can be configured in a MongoDB on startup? Well, we go to the image documentation, and right here we see the environment variable names for username and password. And these are actually required fields in most of the databases. We have to set them, otherwise we won't be able to access them. So the next question is, how do we configure environment variables in a container configuration? So how do we pass environment variables to this application running inside the container? Well, that's also very easy. We have env attribute for that, which is a list of environment variables with names and values. That's it. So very simple. So name is the environment variable name and value is the environment variable value. So let's copy the name. So this is the environment variable name that MongoDB expects, and we have to set a value, whatever we want the username to be. Now we can directly set the username right here, like this, or in our case, we're gonna reference them from secret and config components. How do we do that? Also pretty simple. We do value from, and we want to reference it.
I like it.
From the secret. So we do secret key ref, and under that we have the name of the secret, which we called Mongo secret, and the key, which is Mongo user. So Kubernetes will basically find a secret with this name and get the value set for this key and substitute it as a value for this environment variable.
Okay.
And the same way, we're gonna configure password. So let's take the password. That's the name of the environment variable. Same secret component, this time with a different key. And that's it. So our MongoDB configuration file is complete. And when it starts, a user with these credentials will be created. When our web application starts, it will need to connect to the database. So we need to give this web application information about the database endpoint, where can it access the database, and
guys, I gotta use the restroom. I'll be back. Okay, back. Let's go.
Name and password to use to authenticate with the database. And I have already configured this application inside to expect all these values as environment variables with specific names. So we're gonna pass these 3 pieces of data as environment variables to the web app application. So let's do that. Again, the name of the environment variable, the first one I actually called username. And we can actually copy the same configuration and paste it here. And you already see an advantage of using configuration from secret or config, because if you need the same information in 10 different applications, you create it once and reference it 10 times. The second environment variable is for password. And I called this one user pwd. And finally, our application needs the database endpoint, which will be db URL. And this value is not in the secret, but in config map. And how do we access value from config map? Very similar as the secret, so we have the same value from.
Okay.
And instead of secret key ref, we have
really cold today, yo. Jesus.
Map key ref or key reference. And then we have name, which we called Mongo config, and key, which is the name of the key. And that's it. So we don't have any of
All right, I gotta listen to this one more time.
URL. And this value is not in the secret, but in config map. And how do we access value from config map? Very similar as the secret, so we have the same value from. And instead of secret key ref, we have config map key ref or key reference. And then we have name, which we called Mongo config, and key, which is the name of the key.
Ooh.
And that's it.
I
So we
like
don't have
it.
any of the configuration values hard-coded in our Kubernetes configuration files. We only have references, which makes our configuration way cleaner. So if something changes or the values change here, we don't have to adjust anything in our deployments.
This is
So
so
connectivity with the database is configured, and there is one last thing missing in our web application configuration before we deploy all of this, which is making it accessible from the browser. We want to be able to type in some URL and access our web application from the browser, right? And as you learned, we have external services for that. So we will need to adjust the service configuration a little bit. Right now, these service configurations, both of them, are internal services. So to make it external, all we need to do is set a type, which is by default cluster IP. So that's the default type if we don't specify the type, but we're going to set it to node port. So node port is an external service type, and it requires a third port, which is called a node port. So what is a node port? This is a port which will open on the Kubernetes nodes on which the application will be accessible. So on the node IP address and node port combination, we will be able to access this service, which will then access the pods behind it. And node port range is actually defined in Kubernetes, so we can't just type anything we want here like this. It has to be within the range of 30,000 and 32,767. So anything within this range is fine as a value. So we can do 30,000 or 30,100, doesn't really matter. So let's set this as a value, and this completes the web app configuration file. Now we have a very simple but also pretty realistic configuration for deploying an application with its database with external configuration in the cluster. So as a final step, we're just gonna create all these components one by one in Kubernetes. So I'm gonna open a terminal, and we already have a Minikube cluster running, but there are no components inside. So first, we need to create the external configurations because they need to be there when we create MongoDB and web application deployments, because they reference those configurations. So let's create Mongo config and secret first. To do that, we have kubectl apply command with -f, which stands for file, which takes a Kubernetes configuration file as an input, like this, and creates whatever is defined inside. And as you see, Mongo config was created. Now let's create Mongo secret. Next, we're gonna create a database because our web application depends on it. So it should start first. And again, let's do kubectl apply with mongo.yaml as an input. And as you see, deployment and service were created. And finally, let's deploy our web application. And there you go. So everything seems fine. But of course, we want to check all the pods and all the components that were created in the cluster.
What is the most used language in programming?
So for that, I'm going to actually switch to command line so that we can see better. And first, we're going to do kubectl get all.
You got me, motherfucker!
All the components created in the cluster, which includes deployments, the pods behind the deployment, and all the services. And as you see, we have Mongo deployment and web app deployment pods, each one with one replica running. And we have the services for MongoDB and web app. And web app service is of node port type, which means we can access it externally.
The past week.
However, we don't see config map and secret here.
I have it resolved, bro. So you can, like move over and relax.
And kubectl get secret commands. So as you see, displaying any component is pretty easy. Using kubectl, you just do kubectl get and the name of the component, like pod, and you get a list of those components with some additional data. And kubectl is actually a very powerful tool, and it has a bunch of subcommands. So as a natural documentation for kubectl, to basically have an overview and see what you can do with it, you can always use kubectl help as a documentation, which lists all the subcommands you can use with it. One of them, which we already used, get, and for each subcommand, like kubectl get, you can also get some help and basically see all the examples plus all the available options. So you can navigate all the options you have here. So kubectl get is obviously the most common command you're going to use to list all the components. If you want to see more details about a certain component, you can use kubectl describe command for it, a name of the component, like a service, for example, and the actual instance of that component, like web app service. And this will give you more detailed output about that specific component. Same way you can also do kubectl describe pod and then name of the pod, like this one. And this will give you details about your pod, including the status of how the pod was scheduled, the container configuration, labels, etc. And finally, of course, when you have applications running in your cluster, you want to check the logs to troubleshoot, debug, or just make sure that everything is fine within the pod. And you can do that very easily using kubectl logs command and just specifying name of the pod, like this. This gives you logs of the container inside, and you can even stream the logs using -f option. So as a final step, we want to validate that our application is also accessible from the browser. And for that, we actually configured the service. And we can actually get the service using service or svc command. So how do we access this service from the browser? Because this is the port we're going to use to access it, but which IP address is it accessible at? Well, the node port service is always accessible at the IP address of the cluster node. So all the worker nodes that the cluster has. In our case, we just have one, which is the minikube. So we need the IP address of the minikube. To get that, we just do minikube IP, or using Kubernetes, we can also get node, which gives you minikube and a wide output or a longer output than what you see here, which will give you the IP address of the node, which is the same as this one right here. And by the way, you can use the all wide option for any other get command for services, pods, etc. to get some additional information like this.
There's a cat hair right around my mouth.
The minikube IP address and access the application at this port, which is 30,100. And there you go. This is our web application, which is connected to MongoDB. And we can also validate that by editing something. And saving, because this request goes to the database. And if we refresh, the changes should still be there. Awesome. So we deployed an application with its database in Kubernetes, which is a blueprint configuration for most common application
This is really sick,
you're going to have.
Like,
Plus,
I'm
you also learn a couple of kubectl commands, as well as how to reference the Kubernetes official documentation to help you configure and create all the components. I hope I helped you learn a lot about Kubernetes with this crash course, and you feel much more confident with Kubernetes. Now, if you're serious about learning Kubernetes in depth, I actually have 2 more resources for you. As I mentioned at the beginning, if you want to really become an expert in Kubernetes and learn how to build and administer a cluster from scratch, then my complete Kubernetes administrator course will be a perfect resource for you. But if your goal is rather to become a DevOps engineer, then our complete DevOps educational program will be the best fit for you, where during a 6-month program, you learn all the necessary concepts and technologies, including Kubernetes, which you need to get started in DevOps or cloud engineering. If you're interested, you can find the links in the video description below. And with that, thank you for watching and see you in the next video.
Hell yeah, let's give it a thumbs up. That's what I'm talking about. Thanks for this tutorial, Nana. Greatly helped. Show support. Right. Okay, I think I'm gonna like implement this step by step, and I'm gonna try to translate this into my setup. So I think the question that I have right now, since this already a service you can create in Kubernetes already does load balancing for you, do I really need Nginx? Because I'm setting up Nginx to sit in front of my Django instances running. And then one thing that Nginx is doing actually is that before it sends the request to any of the running Django instances, it checks the size of the thing, and then it assigns the, what you gonna call this thing, assigns the SSL certificates, because, right, like that's how I'm gonna be setting up the TLS. So I use Nginx as a reverse proxy myself. I've never used it as a load balancer before. Like my setup right now is using it as a load balancer. I might have disabled it, but let's actually check it out. So if we look at this, I think Nginx conf right here. Yeah, so you can create like as many upstream as you want. I'm sorry, as many servers as you want inside the upstream API. And then it's just gonna like keep deviating, like keep sending it depending on the load for you. So like it should be like very straightforward. So like you do it like proxy pass right here. And then you tell which one, HTTP API, meaning the one that you declared right here. I would think you'd want to utilize the existing Kubernetes load balancing technique since it's more integrated. Yeah, I wonder if you can define a request size in the service. Kubernetes service request size limit. Okay, if that is a thing, each container has a limit. No. Object size. No. I want the request size, bro. Yeah, because this is what's going to happen. My maximum size is going to be 64 megabyte. I got a bit hard on the ass by not defining my request size in Nginx. Yeah, I think by default, like it's 1 megabyte apparently. I'm not really sure, but like I had to set up mine. Now mine is 64 megabits, actually not megabytes, megabits. It was too small to work with during the identity and took forever to figure out what the problem was. Oh, yeah. I got hit with the same problem, then I had to configure it. Because I like that I'm able to do that with Nginx before it even hits my Django instances, because like Nginx sitting on the front and telling the request to fuck off before it even like forwards all that stuff to be identified by Django, right? Otherwise, Django has to like check it out itself and then say no. They're just talking about like hardware. Talking about the incoming request payload. Fuck. Nginx Proxy Manager is technically what I use. Makes Nginx kind of easy mode, but also abstracts a lot. Yeah, I really like that, you know, the amount of things that it gives you for whatchamacall this thing, the configuration options, but it can get like quite tedious. But I still like the way it comes out of the box, because other things are like already like set with the default values, and you only configure the things that is affecting you or things that you actually want change. Now I'm trying to set payload limit, Kubernetes service request payload limit. Payload. Actually, fuck the size. Let's just say payload. Large enough payload to contain large payload for custom objects. Resource management for limit ranges. Kubernetes Nginx service request payload limit. I don't know the default. No. I think Nginx is just overtaking here. Okay, I'm gonna do another search here. I'm gonna say Kubernetes Nginx as service, so it can do the load balancing. Nginx ingress. I think this is what it is. And then 8 months ago, let's check this out. See if this is gonna give us some good information we can use. 38 fucking minutes though. Jesus, bro.
So you've taken the journey of learning Kubernetes, and you've heard about Kubernetes Ingress, which essentially helps you send traffic from the internet to your services running in your cluster. Now, if you want to use Ingress in Kubernetes as a feature, you need to learn about Ingress controllers. In this video, we'll take a look at how to use the Nginx Ingress controller. We're going to take a look at the installation process, some of the important and powerful features, and some real-world examples. We got a lot to cover in this video, so without further ado, let's go.
Let's go! What? Ah.
For Ingress, any type of proxy, in our case Nginx. An Ingress controller listens for Ingress objects. When an Ingress YAML is applied to the cluster, it automatically synchronizes this with Nginx. By gracefully updating the Nginx configuration, we can send traffic based on domain and path to different services.
Okay, let's do it.
So if you take a look at my GitHub repo, I have a Kubernetes folder, and in here I have everything related to Kubernetes. I have an Ingress folder, and under the Ingress folder I have a controller folder, and this is my folders where all my Ingress controller guides are located.
That looks
Today
scary
we're going
to
to be taking
Too
a
many
look at
fucking
Nginx.
files there.
If I go down there, you can see we have a README file, and this is our introduction to Nginx Ingress controller. We're going to take a look at spinning up a Kubernetes cluster, installing some tools, and essentially installing the Nginx Ingress controller. Take a look at all the features, and everything that I've done is documented in this GitHub repo. So be sure to check out the link down below to the source code so you can follow along.
Not the YouTube itself.
Now, the first step in our guide is to create a Kubernetes cluster. Now for this, I'd like to use a utility called Kind, which helps us run lightweight Kubernetes clusters in Docker containers. This guy is the most jacked
DevOps guy I've ever seen in my life, bro.
As we want. It starts up really quickly, and we can throw them away once we're done. So to create a cluster, it's very simple. I just say Kind create cluster. I'm going to call this one Nginx Ingress. So I give it a name, and I'm going to run Kubernetes 1.23.5. So I go ahead and copy this, paste it to the terminal, and that will create a new Kubernetes cluster that we can use for testing. Once that command is finished, you can see we now have a Kubernetes cluster up and running, ready to go. And to see my cluster up and running, I simply say kubectl get nodes. And when I run that, we can see we have a one node Kubernetes cluster up and running. Now the next thing I'm going to do is run a lightweight Alpine container on my machine to install some utilities. And the reason why I do this is for portability, because most of you are running Linux environments. You may use tools like JQ, curl, wget, and other utilities such as kubectl and Helm. I'm going to create this lightweight Alpine container, install all of the dependencies that I need for this demo. And this is very simple. All I do is say docker run -it. I want to remove the container when it's done. I want to mount my home directory into the home directory of the container. This is so that I can access my Kubernetes cluster, because the .kube folder is also inside there. So kubectl will use that kube config file. And then I also mount the working directory. That is the directory we are in at the moment for this repo, into the work folder, and I set my working directory to /work. Then I want to run my container on the host network as well, and simply create a small Alpine container with a shell terminal. I go ahead and copy this, paste it to the terminal, and I have a container. If I do ls -l, we can see I have all the files here that are all the files on the left hand side. Now I'm going to go ahead and install some utilities. I install curl. So I just say apk add, install curl, and then I use curl to download and install kubectl. So a simple command, curl get kubectl, give it chmod execution rights, and move it to user local bin. Go ahead and copy paste that to the terminal, and that'll install kubectl inside of the container. Go ahead and clear the terminal, and now I can install Helm. So I say curl, the same way I downloaded kubectl, I'm going to grab the Helm tar file, I'm going to extract it using tar, I'm going to move it to user local bin and give it execute permissions. Go ahead and paste that to the terminal, and that'll install Helm CLI in my container. So now I can say kubectl get nodes, we can access our cluster, I can also say Helm, and I have Helm installed. And this is because we're going to be using Helm to deploy the Nginx Ingress controller, or at least manage the templates. Now there are a number of ways you can deploy the Nginx Ingress controller. You can install it directly using the Helm chart, or you can use the Helm template command to grab the manifest manifests and then store that in your Git repo and use something like Flux or a GitOps pipeline to deploy it. I like to just get the manifests and deploy them myself. This means I can look at the manifest, I can compare it with older versions, and I can see exactly what's going to change. I can also take that YAML files and store it inside my Git repo and keep it as my infrastructure source of truth. So before we continue, just a quick word from our sponsor who made this video possible. So you have Kubernetes clusters. How many operations are easy to install Kubernetes and configured detailed view of each better Kubernetes is sponsored by Detree. Remember to check out the link down Ingress documentation. Now there's two Ingress controllers, so don't get it messed up. One is managed by Nginx, the other one is managed by the Kubernetes Nginx community. You can find the link in my README file right here. This is the documentation for the Ingress controller. Now on the right hand side here, there's also a GitHub link. If you go to that, you will get to their GitHub repo, which has an overview page, a getting started guide, as well as an important part that I like to emphasize on, which is the supported versions table. This is very important when you're deploying Kubernetes cluster, that you make sure that the Nginx Ingress version is compatible with the Kubernetes version. So you have to make sure you pick one that is either forwards and backwards compatible. If you
does he have a link to that? Source code? No. Okay, I think it's like we're gonna have to find it on his own GitHub. Let's see. Where are we right now? Docker development YouTube series, Python Kubernetes. I think it was over here. And then he had Ingress, and then controller, and then Nginx. And read me, please. Thank you. Okay, this one over here. Bro, there is no light version. Jesus, my retinas. You can't fucking do TLS. No. I'm opening up a whole new world on my own head. God damn it. All right, let's go.
If you're going to be doing cluster upgrades, so
this feels like this video requires me to have more. Oh, this is the same guy. What is this video? 14 minutes. 20 Ingress. Simply explained. Okay, tech world. Oh, it's the same lady. Yeah, let's see if she will tell us.
So in this video, we're going to talk about what Ingress is and how you should use it, and also...
I'll be back. Give me a sec. I'm going to check on my kitty. Mr. Kitty. Okay, back and let this suffering continue.
Also, what are the different use cases for ingress? So first of all, let's imagine a simple Kubernetes cluster where we have a pod of my application and its corresponding service, my app service. So the first thing you need for a UI application is to be accessible through browser, right? So for external requests to be able to reach your application. So one way to do that, an easy way, is through an external service where basically you can access the application using HTTP protocol, the IP address of the node and the port. However, this is good for test cases and if you want to try something very fast, but this is not what the
Norpai, how we doing?
The final product should be like this. So you have a domain name for application and you want a secure connection.
We are so cool.
HTTPS. So the way to do that is using Kubernetes component called ingress. So you'll have
I missed the explanation, sorry.
Service where basically you can access the
I'm gonna listen to it again.
using HTTP protocol, the IP address of the node and the port. However, this is good for test cases and if you want to try something very fast, but this is not what the final product should look like. The final product should be like this. So you have a domain name for application and you want a secure connection using HTTPS. So the way to do that is using Kubernetes component called ingress. So you'll have a my app ingress and instead of external service, you would instead have an internal service. So you would not open your application through the IP address and the port. And now if the request comes from the browser, it's gonna first reach the ingress and ingress then will redirect it to the internal service and then it will eventually end up with the pod. So now let's actually take a look and see how external...
Being late. I was calling from yesterday morning 2:30 till today's morning 9. Had to sleep. That is some schedule right there you got, man. Why so late? Is it because like a preference or you get a deadline?
Your application through the IP address and the port. And now if the request comes from the browser, it's gonna first
deadline
ingress and ingress then will
redirect
it to the internal service and then it will eventually end up with the pod. So now let's actually take a look and see how external service configuration looks like so that you have a practical understanding. So first of all, if you want to know in more details how Kubernetes YAML files are written and what the syntax looks like for different components, then I have a separate video so you can check it out. But here just to understand the main concepts, so you have the service, which is of type load balancer.
I hate it and I still don't see the use case, but hey, it works.
By assigning an
You've
external
done your
IP
duty
address to the service. And this is the port number that user can access the application.
Let me look at this one more time.
See how
sorry, I gotta do it like
configuration
triple take
looks
sometimes.
like so that you have a practical understanding. So first of all, if you want to know in more details how Kubernetes YAML files are written and what the syntax looks like for different components, then I have a separate video so you can check it out. But here just to understand the main concepts, so you have the service, which is of type load balancer. This means we are opening it to public by assigning an external IP address to the service. And this is the port number that user can access the application at. So basically, the IP address, the external IP address, and the port number that you specify here. Again, if you want to know more details about each attribute, then check out my Kubernetes YAML video. Now with ingress, of course, it looks differently. So let's go through the syntax of ingress. Basically, you have a kind ingress instead of a service. And in the specification where the whole configuration happens, you have so-called rules or routing rules. And this basically defines that your domain address or all the requests to that host must be forwarded to an internal service. So this is the host that user will enter in the browser, and in ingress you just define a mapping. So what happens when that request to that host gets issued, you redirect it internally to a service. The path here basically means the URL path. So everything after the domain name, so slash whatever path comes after that, you can define those rules here. And we'll see some different examples of the path configuration later. And as you see here in this configuration, we have an HTTP protocol. So later in this video, I'm going to show you how to configure HTTPS connection using Ingress component.
Nice.
So right now in the specification, we don't have anything configured for
hold
secure
on.
connection.
New message. I don't see any reason why someone ever should encrypt an Argon2 password hash with SHA-256, but hey, now I have a working login routine which does exactly that in less than a second. Okay. That is like part of the project, part of the deadline that you had to do. And did you create it in Python or is it like something else?
Connection is just HTTP. And one thing to note here is that this HTTP attribute here does not correspond to this one here. This is a protocol that the incoming request gets forwarded to the internal service. So this is actually the second step, and not to confuse it with this one. And now let's see how the internal service to that ingress will look like. So basically backend is the target where the request, the incoming request will be redirected, and the service name should correspond to the internal service name like this, and the port should be the internal service port. And as you see here,
so it sits on top of the service.
Between the external and internal services is that here in internal service, I don't have the third port, which is the node port starting from 30,000. We now have that attribute here, and the type is a default type, not a load balancer, but internal service type, which is cluster IP. So this should be a valid domain address. So you can't just write anything here. It has to be, first of all, valid, and you should map that domain name to IP address of the node that represents an entry point to your Kubernetes cluster. So for example, if you decide that one of the nodes inside the Kubernetes cluster is going to be the entry point, then you should map this to the IP address of that node. Or, and we will see that later, if you configure a server outside of the Kubernetes cluster that will become the entry point to your Kubernetes cluster, then you should map this host name to the IP address of that server. So now that we saw what Kubernetes Ingress components looks like, let's see how to actually configure Ingress in the cluster. So remember this diagram I showed you at the beginning? So basically you have a pod, service, and corresponding ingress. Now, if you create that ingress component alone, that won't be enough. For ingress,
what took me the most time was writing the test for this shit.
What you need in addition is an implementation.
Testing.
Ingress.
The fun part.
Implementation is called ingress controller. So the step one will be to install an ingress controllers, which is basically another pod or another set of pods that run on your node in your Kubernetes cluster and does evaluation and processing of ingress rules. So the YAML file that I showed you with the ingress component is basically this part right here, and this has to be additionally installed in Kubernetes cluster. So what is ingress controller exactly? The function of ingress controller is to evaluate all the rules that you have defined in your cluster, and this way to manage all the redirections. So basically this will be the entry point in the cluster for all the requests to that domain or subdomain rules that you've configured, and this will evaluate all the rules because you may have 50 rules or 50 ingress components created in your cluster. It will evaluate all the rules and decide based on that which forwarding rule applies for that specific request. So in order to install this implementation of ingress in your cluster, you have to decide which one of many different third-party implementations you want to choose from. I'll put a link of the whole list in the description where you see different kinds of ingress controllers you can choose from. There is one from Kubernetes itself, which is Kubernetes Nginx Ingress Controller, but there are others as well. So once you install Ingress Controller in your cluster, you're good to go, create ingress roles, and the whole configuration is going to work. So now that I've shown you how ingress can be used in a Kubernetes cluster, there is one thing that I think is important to understand in terms of setting up the whole cluster to be.
I'm actually happy with the result. Average login time over 100 iterations, 0.03 seconds. That's fast as fuck. That sounds fast as fuck, especially for Python. Bruh. I didn't know that Python could like hash that fast. But good job, man. I'm guessing everyone is happy with the result.
To be able to receive external requests. Now, first of all, you have to consider the environment where your Kubernetes cluster is running. If you're using some cloud service provider, like Amazon Web Services, Google Cloud, Lino, there are a couple more that have out-of-the-box Kubernetes solutions, or they have their own virtualized load balancers, etc. Your cluster configuration would look something like this. So you would have a cloud load balancer.
I don't care. I did what they asked. They pay what they got.
That is specifically implemented.
I've done as I'm told. My responsibilities are over.
And external requests coming from the browser will first hit the load balancer, and that load balancer then will redirect the request to ingress controller. Now, this is not the only way to do it. Even in cloud environment, you can do it in couple.
Okay, let me actually check this out because I'm going to be using DigitalOcean. I want to make sure that it doesn't force me to do that. So apparently we were doing that. That's why it looks weird. Scale automatically. Cross auto scale to seem okay. I'm trying to see the fucking. I mean, what the fuck should anyone encrypt the password hash with if it says it's only more secure if someone gets a DB dump but doesn't have access to the code? Hold on, let me read this again. Anyone should encrypt the password with hash with it's only more secure if someone gets a DB dump but doesn't have access to the code. Hold on. Are you trying to say that you would store it like plain? Oh, okay. Because like you would do, yeah, you would hash it one way. Like you would do it unhashable because when you are matching a password, you don't decrypt it and then match it. You take the incoming value, you encrypt it the same way you would encrypt before storing, and then compare the values against each other. That's redundant. Like, what the fuck the point is? Maybe it's like a regulation thing or something, you know? Because if there's already like one-way hash, you don't really need to do hash to hash. Like, what the hell, right? Maybe maybe somebody's being a little paranoid. DigitalOcean Kubernetes ingress. Okay, they looks like they have a thing already. The only logical reason why this would make any sense is post-quantum security, because it's still considered post-quantum secure. Oh, gotcha. Maybe it's like a regulation thing or like a business contract, you know, like meeting the requirements of a contract, maybe. It's a 4-digit contract for me, so I did what I got asked for. I mean, yeah, you do whatever that's asked of you that you agreed to do. I guess that's it. I do whatever pays me rent except WordPress. That's a good bundle to have. Fuck WordPress, bro. I I will probably have to touch it, like create a plugin for it for my service so it can be used in WordPress. WordPress being the most widely used fucking framework out there, and I want to be in there, but still, it fuck. Okay, the Nginx controller as a load balancer, and the external IP is going to be assigned. Cool, 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 cool. Okay, that should work. I'd rather pay some Indian dude for it than ever put hands on WordPress. You hate it that much? I mean, it wouldn't be like difficult to find someone who does WordPress. There's like, million of them, bro. But so many WordPress experts out there.
This is one of the most common strategies. And advantage of using cloud provider for that is that you don't have to implement a load balancer yourself. So with minimal effort, probably on most cloud providers, you will have the load balancer up and running and ready to receive those requests and forward those requests then to your Kubernetes cluster. So very easy setup. Now, if you're deploying your Kubernetes cluster on a bare metal.
Hold on, my cat is meowing like his ass off. Let me see what he wants. Also, I'm gonna use the restroom real quick. All right, Mr. Key, where's my boy? It's so dark, I can't see you. Oh, look at it, boy. Fuck, it's so cold. My kid's outside under the goddamn snow. Like, he doesn't care.
Environment, then you would have to do that part yourself. So basically you would have to configure some kind of entry point to your Kubernetes cluster yourself. And there's a whole list of different ways to do that, and I'm gonna put that also in the description. But generally speaking, either inside of a cluster or outside as a separate server, you will have to provide an entry point. And one of those types is an external proxy server, which can be a software or hardware solution that will take a role of that load balancer and entry point to your cluster. So basically what this would mean is that you will have a separate server, and you would give this a public IP address, and you would open the ports in order for the requests to be accepted. And this proxy server then will act as an entry point to your cluster. So this will be the only one accessible externally. So none of the servers in your Kubernetes cluster will have publicly accessible IP address, which is obviously a very good security practice. So all the requests will enter the proxy server, and that will then redirect the request to ingress controller, and ingress controller will then decide which ingress rule applies to that specific request, and the whole internal request forwarding will happen. So as I said, there are different ways to configure that and to set it up depending on which environment you are and also which approach you choose. But I think it's a very important concept to understand how the whole cluster setup works. So in my case, since I'm using Minikube to demonstrate all of this on my laptop, the setup will be pretty easy. And even though this might not apply exactly to your
I have a stand-up desk, but I didn't.
Still, you will see in practice how all these things work. So the first thing is to install ingress controller in Minikube. And the way to do that is by executing Minikube add-ons enable ingress. So what this does is automatically configures or automatically starts the Kubernetes Nginx implementation of ingress controller. So that's one of the many third-party implementations which you can also safely use in production environments, not just Minikube, but this is what Minikube actually offers you out of the box. So with one simple command, ingress controller will be configured in your cluster. And if you do kubectl get pod in a kube system namespace, you will see the Nginx ingress controller pod running in your cluster. So once I have ingress controller installed, now I can create an ingress rule system namespace. So with one simple command, ingress controller will be configured in your cluster. And if you do kubectl get pod in a kube system namespace, you will see the Nginx ingress controller pod running in your cluster.
Get pod kube system. Kubectl get pods. What is the command? Kube system. Where do I see this? I see kube controller manager Minikube API server Minikube. This is Minikube Nginx ingress controller. I don't see that. Did I miss a fucking step? I still don't see that shit. All right, let's go.
Simple command, ingress controller will be configured in your cluster. And if you do kubectl get pod in a kube system namespace, you will see the Nginx ingress controller pod running in your cluster. So once I have ingress controller installed, now I can create an ingress rule that the controller can evaluate. So let's actually head over to the command line where I'm going to create ingress rule for Kubernetes dashboard component. So in my Minikube cluster, I have Kubernetes dashboard, which is right now not accessible externally. So what I'm going to do is, since I already have internal service for Kubernetes dashboard and a pod for that, I'm going to configure an ingress rule for the dashboard so I can access it from a browser using some domain name. So this shows me all the components that I have in Kubernetes dashboard. And since I already have internal service,
let me see what's happening here. Can you guys see me? I'm still here, right? Right. Updating, running container, preparing Kubernetes and Docker 24/7. Okay. Some dispatch which is required in metro server. Okay, now I see the using registry ingress nginx. I think that I still don't see it. What the fuck? Okay, let's see.
For Kubernetes dashboard and the pod that's running, I can now create an ingress rule in order to access the Kubernetes dashboard using some host name. So let's go ahead and do that. So I'm going to create an ingress for Kubernetes dashboard. So these are just metadata. The name is going to be dashboard ingress, and the namespace is going to be in the same namespace as the service and pod. So in the specification, we are going to define the rules. So the first rule is the host name. I'm going to define dashboard.com. And the HTTP forwarding to internal service path, let's leave it at old path. And this is the backend of the service. So service name will be what we saw here. So this is the service name. And service port is where the service listens. So this is actually 80 right here. And this will be it. That's the ingress configuration for forwarding every request that is directed to dashboard.com to internal Kubernetes dashboard service. And we know it's internal because its type is cluster IP. So no external IP address. So obviously I just made up host name dashboard.com. It's not registered anywhere, and I also didn't configure anywhere which IP address this host name should resolve to. And this is something that you will always have to configure. So first of all, let's actually create that ingress rule. So kubectl apply, and it's called dashboard ingress. YAML. See, ingress was created. So if I do get ingress in the namespace, I should see my ingress here.
Isn't the registered domain?
This is now empty because it takes a little bit of time to assign the address to ingress. So we'll have to wait for that to get the IP address that will map to this host. So I'm just gonna watch this, and I see that address was assigned. So what I'm gonna do now is that I'm gonna take that address, and in my
she's gonna edit the host file,
etc hosts file, at the end I'm gonna define that mapping. So that IP address will be mapped to dashboard.com. And again, this works locally. If I'm gonna type dashboard.com in the browser, this will be the IP address that it's gonna be mapped to, which basically means that the request will come into my Minikube cluster, will be handed over to Ingress controller, and Ingress controller then will go and evaluate this rule that I've defined here and forward that request to the service. So this is all the configuration we need. So now I'm gonna go and enter dashboard.com, and I will see my Kubernetes dashboard here.
I like it.
So Ingress also has something called a default backend. So if I do kubectl describe ingress, the name of the ingress and the namespace, I'll get this output, and here there's an attribute called default backend that maps to default HTTP backend port 80. So what this means is that whenever a request comes into the Kubernetes cluster, that is not mapped to any backend, so there is no rule for mapping that request to a service, then this default backend is used to handle that request. So obviously, if you don't have this service created or defined,
you wanted to get the dashboard.com.
Kubernetes will try to forward it to the service. It won't find it.
I would be extremely surprised if that was actually available.
Response. So for example, if I entered some path that I haven't configured, I just get page not found. So a good usage for that is to define custom error messages when a page isn't found, when a request comes in that you can't handle or the application can handle, so that users still see some meaningful error message or just a custom page where you can redirect them to your homepage or something like this. So all you have to do is create an internal service with the same name.
I really should stop that. I'm a big domain hoarder. I have like 50 right now, which is kind of nuts.
Pod or application.
I used to have more. I just let them go.
That custom error message response.
Wait, what's your domain registrar
I have shown
you
you what
use?
ingress is and how you can use it. I've also shown you a demo of how to create an ingress rule in Minikube, but we've used only a very basic ingress YAML configuration. Just a simple forwarding to
Hetzner domain robot? What? Hetzner. Without customer domains, I have like 46 at the moment. Bruh. Domain registration from £12. Fuck. Not cheap. Brother. .com. 16 pounds? Bruh. Hold on, 16 euros, not pounds. With customer domains, I have 87. Bro. Yeah, currently I am using name.com, but it gotten so expensive. Hold on, I think you opened the door. I'm gonna check it and then come back. $16 per year. Yeah. Fuck. Still a lot of money. Let me see if I can get this higher without breaking something. Something is getting in the way here. Okay, let's not break the fucking cable. Get over here. Okay. Not pulling anything hard, right? No. Okay, almost there. Not bad. Huh? Not bad, yeah? Yeah? Yeah. The camera is not... should be like this. Maybe you should like zoom out a little bit. Maybe just a tad more. Okay, this is much better.
With one path, but you can do much more with ingress configuration than just basic forwarding. And in the next section, we're gonna go through more use cases of how you can define more fine granular routing for applications inside Kubernetes cluster. So the first thing is defining multiple paths of the same host. So consider following use case. Google has one domain but has many services that it offers. So for example, if you have a Google account, you can use its analytics, you can use its shopping, you have a calendar, you have a Gmail, etc. So all of these are separate applications that are accessible with the same domain. So consider you have an application that does something similar. So you offer two separate applications.
Also, trail domain scanning
They're part of the
attempts.
same
If you
ecosystem,
ns
but you
lookup,
still want to have
it is
them
of course a valid
on separate
subdomain, but
URLs.
you will
So
never
what
be
you
able
can
to
do
access
is
it.
that in root you can define the host, which is myapp.com. And in the path section, you can define multiple paths. So if a user wants to access
This
your
is so
analytics
sick. I
application,
fucking love this
they have
shit.
to
This is
enter
what I want.
myapp.com/analytics, and that will forward the request to internal analytics service and the pod. Or if they want to access the shopping application, then the URL for that will be myapp.com/shopping. So this way you can do forwarding with one ingress of the same host to multiple applications using multiple paths. Another use case is when instead of using URLs to make different applications accessible, some companies use subdomains. So instead of having myapp.com/analytics, they create a subdomain analytics.myapp.com. So if you have your application configured that way, your configuration will look like this. So instead of having one host, like in the previous example, and multiple paths here inside, now you have multiple hosts, where each host represents a subdomain. And inside you just have one path that, again, redirects the
So using my own
to
DNS
analytics
server in
service.
my home network, I just
Pretty
use a public
straightforward.
DNS
So
server
now
and
in
route
the
it to a
same
local
request
address.
settings, you have analytics service. And
Okay, what are the benefits
a
of
pod
that
behind
for
it.
you?
Now the request
Just
will look like
out of curiosity.
this, using the subdomain instead of path. And one final topic
Browse
that
to one.
I mentioned that we'll cover here
Ah,
is configuring TLS certificate. Till now, we've only seen ingress configuration for HTTP requests, but it's super easy to configure.
Hold on, I
HTTP
think DigitalOcean load balancers comes with SSL certificates already. Can use domains for my local permissions, including Valkyr SSL certificates. Gotcha. That actually sounds cool, bro. Yeah, I was using Let's Encrypt too. DigitalOcean. Load balancer SSL. I think they do already come with that. For the manage highly available supports only support TLS 1, 2, and 1, 3 for incoming connections. Do not support downgrading incoming connections to 1 or 1, 1. The same limits apply to connections from load balancers to drop less number of load balancers. On your account, and the size of each limit depends on the limit set for your account. We use dynamic resource limits to protect our platform against bad actors. Currently, you can't check your resource limit for load balancers, but you can contact support if you reach the limit and need to increase it. We are working on features allowing you to review this limit in the control panel. Application load balancers do not support direct traffic to specific backends based on URLs, cookies. They don't support IPv6. Oh, come on. Mm-hmm. They have a maximum number of new SSL connections they can establish per second, depending on their size. If this number is exceeded, the underlying type of connection is closely plans and pricing for plans and pricing, plans and pricing, plans and pricing. Cost $12 per month for each node they contain. Each additional node increases the load balancer's maximum request per second by 10,000. New SSL connections per second by 250. Simultaneous connections by 10,000. You can add up to 100 nodes to a load balancer. That's not bad. You can scale load balancers up and down at a time to meet your performance needs. The more nodes the load balancer has, the more requests per second it can maintain. The load balancer's costs are appropriately paid. The number of hours it runs at each size, the amount of hours it runs at each size will be displayed on separate line in your invoice. You can resize the load balancer only once per minute. Performance may be depending on the load balancer's workload. And different zones, therefore we cannot provide specific performance metrics for each load balancer size, and there's no additional cost to use less encrypt with load balancer. SSL pass-through can not themselves generate bandwidth charges. They are bandwidth neutral. The public outbound traffic that originates from your resource and pass towards your bandwidth limit. In this scenario, the bandwidth is reported as part of the load balancer and not attributed to the individual resources behind it. Okay, kind of interesting, but I think we can change it as we go. You can add up to 10 backend droplets by name. If you need to add more than 10 droplets to a load balancer, you can use tag. Okay. Yeah, I'm gonna have to create a virtual private network to put the database on, and then database will be only accessible from within the droplets that are on that network. So yeah, it automatically assigns the thing for us, so we should be good. We're gonna have to do like some trial and error. Guys, I'm gonna go check on my cat again, and I'll be back. Okay. because I'm gonna take a break. I'm gonna go eat my food and then I'll be back. So I'll see you guys in a bit. Let's play this. Right, and then I'm just gonna do BRB. Okay. Yeah, I'm not feeling my best. I think I'm just gonna call it the day today and then continue tomorrow. Yeah, I feel like I'm getting sick. So have a good night, everybody. Thanks for chatting up, and I'll see you guys tomorrow.